Hey, what is up, people? We're going to take a look at something here today that I have never messed with before, and so I have exactly 0% experience with. This happens to be a tachometer out of a 1987 Volkswagen Vanagon, and surprise, surprise, or rather, no surprise, it doesn't work. So, I was actually asked by a couple of guys that I know that run an automotive shop if I could take a look at this, and they say that it just basically it's dead. It just doesn't respond to like any tech input or anything. They were telling me that apparently there used to be a rebuild kit you could get to fix this board that's down here, but I guess you can't get it anymore. I don't know who made it or who sold it or anything like that. So we're going to take this little board out here and see if we can potentially figure out what's going on and if we can get this working again. Because the problem is these are so old that they're apparently not easy to get anymore, and if you do find them, they're like super expensive. So if this one can be made to work again, well, that would be preferable than having to hunt like another one down. Now, I wanted to remove the pointer here, but it doesn't appear like it's very easy to pull off, and I do not want to damage like that movement at all. So I'm going to do instead is I'm actually going to remove this faceplate here. There's a couple of little screws right there that hold it on. And the movement itself is held on in the back right here by these two screws. So we're going to remove these two screws and the faceplate. And I'm just going to try as best as possible to be gentle with it because I don't want to damage the faceplate or the movement. Now, I'm pretty sure that there is nothing wrong with the movement itself because if we check the we can actually use the multimeter here to check resistance across the coil of the movement. We've got the multimeter up there in the corner. We can see that it actually will deflect a bit. So if I touch it back here and back here, right there, we can see that it reads at about 144.8 or so ohms. I think me like wiggling it a little bit here actually causes that to change around a little bit, but you see how it does deflect. So it doesn't appear that the movement itself is the issue. It is going to be something electronic. So let's start off by removing those screws then. And I am going to need a very small screwdriver for these right here. These are they're really thin. Actually, I'll remove these back ones here first. That way I can pull the movement and the faceplate out at the same time. Now, this has 4 pins going to the back, but it only uses 3. It uses a ground line, a 12-volt line, and then it uses a tach input. And it appears that the tach input is basically just gets grounded out, or at least that's what they told me. And they kind of showed me a diagram in a repair manual. So I think that I should be able to at least rig something up or some way of potentially trying to test it. I don't know which pin is which, actually, but that shouldn't be too hard to figure out. As I'm prying up, and there we go. So that case can go away. There's a couple of plastic clips they're holding it in place, so I'm just going to try to pry on this one right here. There we go. I think what I'll do is I'm just going to try to pull this through. And I will desolder them from the back. And that frees up the board. Alright, now I can set this over here where I'm not going to risk damaging it anymore. Or at all. And so that's what we're going to look at. And there's not a whole lot of components on this board. We've got a potentiometer, a couple of capacitors. That right there is also going to be a capacitor. I think that might also be a capacitor. We have resistors. There's a diode. That might be a Zener diode, I'm guessing. And a couple more resistors right there. And there's an IC, like a little 8-pin chip, hiding underneath this sticker here. So, yeah, that's not going to come off cleanly, but let's see what this IC is. Alright, I cleaned all that gunk off, and it says 9225 up here. I don't know if that's a date code. Down here it says SAC 215. So I'm going to have to look up information about that, because I have no idea what this chip actually is. I'm curious to know if this electrolytic here might be problematic. It would be cool if it was just down to like that capacitor just being bad or dry or whatever. And there's the 4 pins for the interface. And unfortunately, I thought that maybe we'd only have traces going to like 3 of them, but all 4 of them actually have traces. We see we've got a tiny little negative symbol right there, so I'm assuming that it means that this must be ground. And then it would just be a matter of figuring out which one is like positive. and which one is tech pin. I think another thing that would probably help out here is if I had a schematic for this board. So I think before I do too much else, I will look up this chip and see if I can find any information about it. And there's not like a ton of stuff on here, so I think it'd be fairly easy to draw up a schematic of it, and then we can maybe like analyze what's supposed to be happening and what's probably likely to have gone bad. So yeah, I will stop it here for a second, and we'll be right back. All right, people. Would you believe me that it's been about 2 weeks since I recorded those last few clips and since I did this schematic? Well, yeah, in one more day, it's going to be about 2 weeks since I did this. And admittedly, this schematic is not very neat and it's a little crammed over on this side. But I mostly wanted to do it just to get an idea of like how stuff was connected on that little board to figure out how this chip was supposed to work. And the good thing is that I was actually able to find a data sheet for this IC, although it's not very complete and it appears that maybe it's missing some pages. It gives us like a bit of a description of how it's supposed to work, a pin out, and like, what each pin is. It's got a sample block diagram here of like a circuit for it. Unfortunately, we don't have a diagram of or a block diagram of the internals of the IC, which I would have liked to have to, see like how stuff is connected to these pins. There is a test circuit here, and then just the ratings and all that stuff. So that's all we get on this data sheet. So I was actually able to use this data sheet to help me out with making sure that all the stuff that I was cooking up here was correct. And there are a few differences between what we have on the board and what they have here on the sample diagram. So, but we can at least see how it's supposed to work. We see here that we have 12 volts coming into this 100 ohm resistor, and that's filtered through the 47 microfarad electrolytic capacitor that was on the board. And I think what might be happening here, it says that 7 is like a regulated voltage, something or other. Let me see what it said. Oh, stabilized supply voltage pin. But since it's hooked up to where the power's coming in, I'm going to guess that that pin there is probably internally like a Zener diode or something, because it says that pin 8 is the supply voltage. So, yeah, that's my best guess there. Like I said, we don't know what's inside of here. I actually tried to look up an internal block diagram and I couldn't find one. So we're just going to have to go off of what we have. And because this is apparently a regulated voltage pin right here, this also goes to the meter. And the other side of the meter, which would be the negative controlled side, is a pin number 5. So I'm guessing between pin number 5 and pin number 1, because that's the only one here that goes directly to ground, there's going to be a transistor in there. And then the rest of the pins take care of adjusting the amount of current to that transistor so that it allows more or less current to the meter to deflect it and to control whether, where it sits. There's that potentiometer that was on the board. I think that might be for like tuning the input to what's shown on the meter so that, it matches, because I don't see any other way of doing that other than with, a bunch of these resistors. But yes, and then the tachometer input, that would be this one, which goes through a 33.2 k ohm resistor. And that goes to the cathode side of this 6.8 volt Zener diode that was on the board. And so my best interpretation of this, and with what was on the data sheet, if we look down here, characteristics right here, it says that the input voltage range without triggering the circuit is negative 20 volts to about half a volt, positive half a volt. And the trigger range is 1.5 to 20 volts. And then it says that the trigger slope is positive going. So I'm interpreting this to mean that the majority of the time, the input is going to sit at like basically like a ground state at least, or something negative. And to trigger it, it's got to go positive above 1.5. So if we look back at the schematic, we see here how this, since it goes in series with this diode to pin number 2, which is the input, it's basically going to limit the input voltage coming in to about no more than 6.8 volts. So one of the things I wanted to test was this Zener diode to make sure that that's working perfect or correctly. And unfortunately, I don't have like a curve tracer or anything. So I'm going to do basically just a very simple test here of the Zener diode. And what I'm going to do is I'm going to apply a negative 12 volts to the anode side of the diode right there. And then to the other side, I'm going to apply positive 12 volts. What I'm going to do is I'm going to hook up the ground here to this point, and I'm going to hook up the positive here. And this is a 1K resistor. So as I turn up the voltage on the power supply, it should top off at no more than about 6.8 volts for that, the voltage across the diode. So I'm going to start raising the voltage. Right now it's at 0. And now we got 1. And as we're going to see, the voltage is going to rise at about the voltage that I'm reading out here. So 2 volts. So it's sitting at about 2 volts. 3, 4, 5, 6. And when I hit 7, this should not rise above like any more than like 6.8. So there's 7. It's reading about 6.67 volts there. So I go to 8 volts and it's staying at about 6.7. 9 volts, but it's still about the same. So, and then at 12 volts, I've still got about 6.7. It's rising up a little bit. I think it's, yeah, I don't have like a super accurate readout here, but as you can see now I got, well, you can't see the power supply, but the power supply is at 13 volts now. And the voltage across this diode is 6.734. So it appears that it is regulating. So I don't think this diode is bad. The other thing I wanted to check was the 47 microfarad 10 volt electrolytic capacitor. And so we're going to hook that up right here. Put it at 120 hertz. So, oh man, it got a massive glare there. Sorry. So 6.1 or 61.1. Let's see. And if I go to measure the ESR on it, it's about 4.2. But this is a really old capacitor. And I mean, I don't know what exactly the ESR on it should have been. But the fact that it reads 61 instead of anything close to 47, I think it just means that it's electrically leaky, which in the circuit that we have probably wouldn't affect it too much, I don't think. Maybe it would throw off the readings a little bit, but I think maybe it would still react to, tachometer input. So the fact that it's apparently not responding at all to anything, I think it's not going to be due to this capacitor, because it's not like shorted or anything. So there wasn't too much else to check here on the board. I did check all the resistors. They all seem fine. I did test these other capacitors. They seem fine, but these are not electrolytic, so they really didn't read too far off from their labeled values. The last other thing here that remained that can be a problem is the IC itself, which is honestly probably the most likely culprit. Now, unfortunately, this is not a chip that I could just go on like, DigiKey or whatever and order. So I actually did go on eBay and I ordered me a pack of 10 of them. So these were shipped from China. And I've always mentioned that I'm always a little skeptical when having to order things like that. But I mean, I don't have any other choice. And they weren't too expensive. So it's not like a big deal. But if we take a look at this, I already have one here out of the pack. Under the microscope, I don't exactly get a warm and fuzzy feeling about it. If we look up here, it looks like the surface has been like laser etched, and the numbers there may have been like re-engraved. So I don't know if this chip is actually going to work. I mean, I really hope it does if this is the problem. And let's see what we got on the bottom here. I'm taking a look at it from the bottom. I don't know if that fills there means anything, IO3. But, I mean, I don't know. So, the only thing we can do, I guess, is try it out and see if it's going to work. The only thing I'm worried about, though, is that there being something funky with this chip, and that it's going to, like, short the meter movement to ground. So, I think I'm not going to connect the meter directly to the circuit. I'm going to maybe put a resistor in line just to limit the current a little bit so I don't, like, burn out the coil, because that just makes things even worse. But then I also needed some way to, potentially try out the circuit to bench test it here. So I had to come up with something. And I thought at first, maybe making something that pulses, like some sort of a pulsing circuit with like an IC or whatever. But then I thought, why not make it a little more practical? And so I built this thing here. I took this motor out of my box of junk motors and all that stuff, and I printed out this little wheel that fits over it. It's got 2 slots here, and that's to simulate the 2 pulses per revolution that the engine inside the vehicle would have made. And so over here on the bottom there, I have one of these optical sensors. So one side is like an emitter, basically like a infrared LED. The other side would be like a phototransistor. And I just wire these. I just solder these wires like straight into the pins right there. Put these little feet up there just to kind of like keep it above the surface there, because the wires have to like stick out. I designed this so the motor would fit in there, and then I thought I was going to use like a zip tie to like strap it down, but I ended up just super gluing it in place. And this motor was originally from a windshield washer fluid pump. I didn't pick it for any particular reason. It's just one of the ones that I found when I was digging through my box. When I hook it up and I try to operate it at like a low voltage to get like a low RPM, it doesn't seem very stable. Like, I don't know what the heck is going on inside of it. It doesn't, I haven't opened it up or anything, but it doesn't look like there's anything bad in there. But sometimes it'll kind of hold like a somewhat of a stable RPM. Other times it kind of fluctuates a little bit, like up and down. And so I thought that was going to be a problem, but ironically, it seems to simulate like a running engine to like a certain degree. So I think it's actually going to be sort of a benefit. And as you can see here, I stuck a piece of this reflective material. That's so we can monitor it with this digital tachometer. So basically, I just shine the light there at it, and we can get a readout of what the shaft speed actually is. And so coming out of the sensor here, the shaft speed is actually going to be doubled due to the fact that it's got 2 slots there. So I made a little circuit here that this is all going to plug into. So the first one here, this is for the emitter, for that infrared LED in the thing. So that's going to plug into like this spot right there and get its power. So that's always on. The phototransistor, that's going to go to this 74LS04. That's a hex inverter IC. So I got the input coming, well, not the input, but the collector from the phototransistor going into the input over here of the first gate on this IC. And I just realized I put this in the wrong spot. This was supposed to be over here. And I have that as a pull-up. And so that goes to the output from the first gate. I have it going off into the next 2 gates. So we got the input here. This is an output. It goes into the input of this one. The output of that one goes into the input of the third one on this side. And that goes to drive this LED so we can see it pulsing. And the reason why I did that is so that I can get either a duty cycle that's either more positive or more negative than the other one, because I'm not sure exactly which one the tach circuit is going to prefer. And then that way I kind of have like an option there. So this would just plug into over this side. So I got the emitter of the phototransistor going straight to ground. So if we test this out, we can actually see the LED that are pulsing. If I turn this here, when the slot there lights up that LED, we should, or allows light to shine through the slot, this LED here should react. Yeah, we saw there it turned on. So yeah, so that's how that's going to work. So I'm going to regulate the speed of the motor with my bench power supply. And just as a little demo here, I can actually show you what the output of that looks like. So I got the scope there on the top left corner. Now, if you notice this LED here, it's blinking kind of weird. That's only because of the refresh rate of the camera there. It's not in sync with what the LED is doing, so it looks a little funky on video. If I lower the speed of the motor, you can see how that affects the flashing of the LED there. But if I hook up this pin right here to the output of the first gate, you can see how I have a pulse there that's positive going. And then if I hook it up to the output of the second gate, you can see how I have a pulse there that's that's negative going, and it's mostly high the majority of the time. So yeah, I have the option there of like either a pulse type. I'm going to have to reassemble this board again, at least put the other components on. I don't have a radial, or I don't have like an axial 47 microfarad capacitor, but I do have this radial one that's a 47 microfarad, and if that would focus, it's a 50 volt cap. It's not a 10 volt cap, but it should work. And like I said, I don't think it's anything with the capacitor, the reason why this isn't working. So we'll try this out. If we still get nothing from the actual meter, then I'll swap out the IC, put a resistor in line with the meter and the board, and we'll try it again and see if it works at all. So, all right, here we go. How about we set the speed of the motor here to about, I was trying to find out what the idle speed of one of those vans should be, and it seems to be somewhere between like, I think I said like 800 to 950 or something like that. So I'm going to try to get the speed here to read about 900. So right there, we're pretty close to about 900. And if we measure the pulse width right here, we should see that we have about 30 hertz due to the fact that we're getting 2 pulses per revolution. And it's fluctuating a bit, as you can tell. This motor is definitely not very stable, but it's very close to about 30 hertz right there. So this is working properly. All right, trying to fit everything here into the shot without making everything look tiny is proving to be a bit of a challenge, but I think I've got it now. So on the board here, the outermost pin is negative or ground. The opposite side is positive, and the signal input is the one next to the positive. The fourth pin, that's between ground and the signal input, appears to be an output of sorts or for an adjustment, but that one's not used, so we're just going to ignore that one. So I'm going to hook up this negative lead here to the ground. This positive one's going to go to the positive, and the signal input is going to go to the second one from the right or the left. And I had to use another little plug-in wall wart for the 12 volt because I'm using my adjustable for the motor. So that's sitting there idling away. And here we go. Here's positive to the meter. You see it didn't do anything. So now let's see what happens if we attach this one to the output of the gate. So right now it's according to the readout on the scope, it should be around a little bit over 900 RPM. So let's see what happens if I plug this in here. And nothing happens there. Nothing happens there. I guess no surprise, except we see that it kind of kills the signal on the scope a bit. Okay, well, let's try one of those ICs that I got. See what happens. One thing I do want to check on this new IC, though, before we pop it in, is that there is no direct short between pin 1 and pin 5, because that would be the driver for the meter. And if that was directly shorted to ground, that would mean that there'd be a ground at this pin continuously, and it would probably fry the meter right away. And there is not. Let's see if there's any other weird things going on here. How about, let's check for any resistance between pin 1 and any of the other pins. And not seeing anything at the 3 kilo ohm range on the meter. If the pin 7 is a Zener, like I think it might be, let's see what happens if we do a diode check there between 7 and ground. So it's going to be that and that. Do we get a... Yeah, that's a diode drop right there. So that's actually somewhat comforting. So let's see what else. There's a bit of a diode drop there. 7 point. I mean, seems to be a diode drop everywhere we go here. Let's well, I'll take it out first. I'll take the old one out from the board, and we'll do a little comparison and see if we get something similar to what we got on here. Even though if this is bad, who knows what exactly we're gonna get, but we'll see. Okay, so I've got the old chip out. Let's see how it compares. So I'm going to hook up negative, or actually it was positive over to this one. And pin number 7, that's about a diode drop there. There. So, geez, diodes everywhere. 2.7 or 2.6. That was about, yeah. So that's very interesting. It's actually very similar to this one. So 2.54 there. 2.63. Then we saw 0.72, nothing. 0.73, nothing. So this is looking pretty promising so far. One thing left to do, let's go ahead and pop it in. So I was about ready to try out the new IC and the board here when I just realized that I forgot something very, very important. I don't have a ground between here and here. So this is like a completely isolated system, basically. The only thing I had was the trigger, which is going to basically just be floating due to the fact that this side here has no reference to this side. So, well, I put the new IC in there, and at least we can still like test it out. I wired in a 100K potentiometer between the meter and the circuit board, and I also extended the leads a little bit here because this is like annoyingly way too close to the meter, and so I'm going to hook up another lead here between grounds. All right, so now it's grounded. I don't have power going to it just yet. Let's bring this up here just so we can see the pulses going into it. So, yeah, so at the moment, let's see what the motor here is idling at. Yeah, close to 900. Let's see, I got about 29.5 hertz on the oscilloscope. So, yeah, that's about right. Let's see, let's apply power to the tachometer. And I don't expect the meter here to do anything due to the fact that this resistor is like basically is at the highest resistance it can be. I'm going to slowly turn it up or turn the resistance down. And we'll see if this needle here starts deflecting. I don't see. Okay, it's all the way down and there is no movement on that needle. Let me back it off a bit. And I will hook up the... jeez. I'm just not winning today. I didn't even hook up the tech input. Oh, man. All right, let's try this again. Now I've got a tech input going into the board here. I've got my ground reference, and we're going to turn down the resistance. So let's see what happens. Oh, I see a little tiny bit of deflection. Or is it? Or is my mind just playing tricks on me now? Yeah, okay, I'm not entirely sure. So I'm going to switch the pulse over to the other output. And we see that it affects the scope reading there. And I'm going to start turning this back down again. I don't see anything. Oh, there it goes. We got movement. And it's fluctuating. Oh, it looks like it's working. Okay, I'm going to turn up the speed on the motor. It's down to under 26 hertz. So let's see what the reading is here. 780, 77. Okay, so it's about close to 800 RPM. And now it just hit 800. So I need to like carefully move this stuff around, and how am I going to do this? Thank you, remote. You're going to help. All right, I'm going to turn up the voltage on the motor. Hey. So, yeah, reading about almost 3,000 RPM there, but we see that the needle is definitely not sitting anywhere near 3,000 RPM. Maybe there's a little bit too much resistance still in that pot. Well, since it seems that it's at least doing okay, I'm just going to completely short it out. That didn't change anything. Yeah, that's not changing at all. And it just dropped completely. Why is that? Oh, I guess maybe it just didn't like the voltage here because I turned the motor down and you saw it kind of deflected a bit there. Yeah. Okay, let's change it over to the opposite polarity. And okay, that one does nothing. So it likes this polarity, but the voltage might not be high enough going into it. Okay, I think I'll need to tweak this a little bit. Okay, round 2 or 3 or whatever we're at. So I put a little MOSFET in here, and that's going to the output from the gates over here. So it's wired in a way that it's going to give us an identical pulse, except that the pull-up voltage is going to be a lot higher. So it should be about 12 volts. So if we hook up power to it, you can see there that I have the meter there now set to 5 volts per division. So we have 2 and then like about 2.5 divisions or a little less. So yeah, that's about 12 volts. So that's still working properly. So I'm going to go ahead and disconnect it. I'll hook it all back up to the meter. And since we saw that the deflection here was totally fine and we didn't get anything funky, I wired the output here from the board to the meter directly. It should be okay. So let's hook it up. All right, here goes nothing. Sweet, that looks pretty good actually. Let's see. RPM we're getting here. Things are getting really crammed right here. So about 846, 852. It's reading about 1,000 on the. Yeah, it's reading about 1,000 RPM right there on the meter, but that's pretty close. I mean, that's definitely a lot better than it was. You know, I really wish this thing had a switch that I could just like click on instead of having to push this button the entire time to keep it going. I'm gonna try my best here to not block it. There we are. Okay, let's turn up the voltage on the motor. And it's reading about 2,900 RPM, and we're sitting just under 3,000 RPM there on the meter. Let's go up a little bit. Just going up little by little here. And we see that the pulse there is shrinking in voltage, which is probably not helping the readout. So I'm going to need like a stronger pull-up resistor. Would have been better if this was like an active circuit, but I'm just doing everything here passively, basically with that resistor. They're pulling it up. Just going to briefly touch it here with this 180 ohm resistor. Let's see if it helps. Yeah, that helps a bit. So we're reading about, that's not exactly, I mean, we've got about 3,600 RPM on the digital tach here, and we have about 4,000 on the readout. Yeah, so it's totally possible that this thing will work correctly in a car, and here I just don't have the exact conditions that it wants in order to give us like a proper readout. But, I mean, it is working, so it seems like it would have been that IC that was bad. Although, since I didn't test it properly the first time, I'm actually curious about putting it back in and seeing what happens. So, in order to satisfy that curiosity, I'm going to put the old chip in. We'll try it again and see if it works. All right, I've put the old chip back in. I've changed nothing else to the circuit. So if we apply 12 volts, let's see if it works or not. If it doesn't work, then for sure it was not like anything to do with that capacitor. If it does work, it's possible that it was just that capacitor because I've changed nothing else. So let's see what happens. Here we go. Hey, it's working? What? So that's reading about 1,500 RPM there, and the meter is reading about 1,500 RPM as well. So, wow, that's crazy. Let's try to get this one here to about 2,000 and see if it matches up with the meter. All right, there's yeah, I got the needle right at about 2,000, and we've got about 1,900 on the digital tach. So that seems pretty accurate, but that potentiometer on the board, you know, probably has to be tweaked. Each chip is probably going to have like slightly different characteristics on the output. So, that's, I mean, that's working. Now I'm curious what happens if I put the original capacitor back on. All right, the old capacitor and the old chip are both on this board. Let's see what happens. I'm kind of hoping it doesn't because that'll point to the capacitor actually being bad. But if it works, then I think there may have been something else wrong with that vehicle and not the tachometer. So let's see. Here goes power. Oh no! I think there was something else wrong with their vehicle, not the tachometer. So yeah, that's yeah, it's pretty close to 2,000 RPM there. So, well, uh, if I would have had this like set up from the get-go, I probably could have tested this out like from the beginning, but I didn't. So, well, I guess I've got to be the bearer of bad news to this guy. That's I mean, I'm shaking this around. It's not like fluctuating or anything. So, yeah, well, I think that's going to do it for this video. I mean, I have no proof that any particular component is bad. So that was quite the journey. Well, I seriously don't know where to go from here. I think I'm just going to have to leave this as is and let this guy know that this appears to be working correctly. So I guess I bought those ICs for nothing. But like I said, they really were not that expensive. So if I do need one for whatever reason, I got them on hand. But yeah, if you've watched this to the end, I guess we're just going to have to leave it here. And thank you for watching. I'll see you guys around the bench.